Professor Wergeles here. We just got the start method finished. We got the end method finished and also get name. We're working on the fourth and final method for our visualizer, which is probably the hardest one that you'll need to spend the most time. Now, in the previous video, I said go and work out your algorithms in audio-visual. This is a little bit easier because you don't need to worry about the start method. You don't need to worry about the end method. You can go and create your algorithms here in the controller, figure out your algorithms, and then bring those over into your visualizer. So this would be the first step. I recommend you go implement your algorithms, then come over here to AudioViz, understand the entire application, look at the examples given, and then go and create your visualizer like what we did here. So that's the exact procedure that I want you to follow. If you follow the lectures, we did media player, then we did audio visualizer, and then we're doing AudioViz. So we're bringing those over into the complete application. Coming back to my controller, I'm going to use the same algorithms that we implemented in audio-visual. Now those algorithms took me a while to finalize. I needed to first figure out what values were coming in. So if I go back to the controller, we just put magnitudes in by default. We saw that made the ellipse disappear. Then we created an offset. And then here I put magnitudes in by default, but the ellipses were moving down instead of up. So we figured out a good formula for that. But then the ellipses were going off the display. So I normalized the values. Then we were rotating objects, but it wasn't rotating enough. So we had a phase multiplier. And then we started changing colors, and we figured out what values we can specify, so we multiply it by -6. So I recommend you do the same. So you pick an object or you pick an idea that you want to implement, come over here and figure out your algorithms, and then bring those over to the AudioViz challenge. Now, if you look at all three visualizers in their update method, they want to make sure the ellipses is not equal to null. As long as the ellipses are not equal to null, we're going to do something. And you'll see all three of them do the same. So even though you don't want to go and take this code and then copy it, you will want to look at the examples so you get an understanding of the workflow. The workflow for all these methods, or the general guidelines that these examples give you, will help you make your visualizer more stable. For example, if I forget this if, then I could experience a runtime error. Or if I don't do the minimum value here, then maybe I have an array out of bounds issue because magnitudes is not always guaranteed to have that corresponding value. So if you look at this program and understand how the examples were written, you can use those concepts in your visualizer to make sure your visualizer is more stable. So I'm going to do the same here in my visualizer. I'm going to have an if statement. I'm going to make sure the ellipses are not equal to null. So if the ellipses are equal to null, there's no reason to continue. So I'm going to have a return. Now, I could do this the other way as well. I could say if the ellipses are not equal to null, then run this code. Both are acceptable. So if they're not equal to null, then this code's going to run. So I'm going to grab the minimum value between the ellipses.length and the magnitudes.length. Now, if you decide to use phases, you may also include that value as well, depending on which one's shortest. So if magnitudes is shortest, you're going to use it. If phases is shortest, you're going to use it. So depending on what value you have here, you may need another minimum to determine whether phases is smallest or not, because whatever value is smallest you'll want to use so your for loop does not cause an array index out of bounds. So then I'm going to generate a for loop that's going to go through the minimum number here. So in the example I'm using, I'm only going to use magnitudes from the algorithms that I created in the previous lecture. Now if I go back to these algorithms, you'll see I had the absolute value multiplied by 5 minus 300. So I'm going to bring that algorithm over. Now in audio-visual, we only had 4 number of bands and they were hard-coded. So I just said ellipse 1, ellipse 2, ellipse 3, ellipse 4. But now in this program, I may have 10 ellipses. I may have 20 or 140 ellipses. So I need this for loop that's going to update the objects on the display. So in the previous example, I had them hard-coded. In this example, I'm going to use a for loop and use the index of the for loop to know which ellipse I'm going to update. So we'll bring the first algorithm over based off the ellipses. So at ellipse I, I'm going to set translate y. So I'm going to move the object on the y-axis, and I'm going to take my formula. So it was the absolute value of magnitudes at the given I index multiplied by 5 minus 300. So that was the first part of my algorithm. Now I recommend you run this. So if I run this, I'm not going to see my visualizer up on the display yet. I need to go and add that in the controller. So if I come back to the controller, make sure you add your visualizer here. If you don't add your visualizer here, then you're not going to see it up on the display. So I'm going to create an instance of my class, make sure it implements the visualizer interface, That way I can add it to this array list without any issues. Run the program, and now you should see your visualizer in the list. So if I select it, here's my ellipses if I do play. So make sure you select an audio file and then play some song. Okay, so here was my algorithm. Now, I recommend just doing one step at a time so you make sure the program works. If I go and I start taking all my algorithms and putting them all in at once, and I get some error, it's going to be hard to debug. So I put one algorithm in, it looks like it's working, so I can add some of the other algorithms in as well. So if I go back to the previous lecture, another thing that we did was we changed the X and Y radius to the magnitudes plus magnitude offset. So I increased the size of the ellipse or the circle based off of the given magnitudes value. So I can add those algorithms in. So based off of the ellipse's eye, I'm going to set radius X to some value. I can copy this, and I'm also going to set radius Y to some value. Now, what was that value? If I go back and look at my algorithm, you'll see I had a magnitude offset plus magnitudes at a given index. So if I bring that algorithm over, I need to create this variable, but I'm going to change the index to I, and that was used in both X and Y. So I increased the circles X and Y at the same corresponding value. So let's create magnitude offset. I'm going to go up to the top. It'll be a custom variable that's very specific to my visualizer. And if you look back at the program for audio visual, you'll see magnitude offset was equal to 70. So I defined that here, and now I don't have any compile errors. So I recommend you run the program again. Now, you'll find it very burdensome to come over here, select open, go to the file chooser, search for an MP3 when I'm just trying to debug the program. So what I recommend, in the controller, in the initialize method, you can tell it to open up a file, maybe at the end of the initialize method. You can call the open media method and then pass in some path to the file on your machine. So you can pass in the file here as a parameter. That way you don't have to keep clicking open each time. So for example, here's a media file. So let's say I use this song here. I can view the properties. It'll tell me the path, so I can grab the path. I can create a new file here, put the path in as a parameter, call open media, and pass that file in. Now when I run the program, you'll see a file opens up by default, and now I can just select play. So it makes it a lot easier to debug. So when I select my visualizer, you'll see it's increasing in Y, so it's moving up. You'll see the clip is working. So if the visualizer moves outside of the interface, the clip handles it and it will cut the object off. And also the ellipse is increasing in size. So it's moving up and also increasing in size. If I change the number of bands, you'll see at this time it's working because I set the start and end methods properly. And if I increase the number of bands, the program still runs smoothly. I still have more to show, but I'll do that in the next video. Stick with Professor Wergeles, and we'll see you in the next video.